Hello, graders of the 5th. Today we're learning about lines of symmetry, and we're kind of reviewing transformations. Remember that those transformations, we can shift those objects around, we can rotate them, and we can reflect them through the three different types of translations, or transformations: translation, reflection, and rotation. The new concept is found on page 688. And this is lesson 105. We're going to find lines of symmetry in figures and determine if a figure has rotational symmetry. Symmetry is kind of the important word for today that we will focus a little bit on now. In this lesson, we will look for lines of symmetry. Figures that can be divided into mirror images by at least one line of symmetry are said to have reflective symmetry. If a mirror is placed upright along a line of symmetry, the reflection in the mirror appears to complete the figure. So basically, I'm going to just I'll make sure it's right. I'll draw a square. Now the lines of symmetry in this square are pretty numerous. Okay, a line of symmetry just splits it directly in half to where if I reflected this image on the other one, if I put a mirror here, it would reflect the exact image on the other side. Okay, I could fold this on top of itself and there would be no spaces, it would be perfect. Now on a square, there are a bunch of lines of symmetry. This would be another one. I'll try to get rid of these. Shoot. Okay, another one could be a horizontal one. With squares, you could actually do these diagonal ones as well. But those ones wouldn't work with the rectangles because if you folded this along this line, it wouldn't line up exactly correct. Okay, so let's look at example 1. Example 1 says, here we show a triangle, a regular triangle, and a regular pentagon. Find the number of lines of symmetry in each figure. So we have a regular triangle, meaning that all the sides and all the angles are the same. Now one line of symmetry I can see right away is the vertical line. It splits it up exactly into two equal parts, and if I folded this corner onto this corner, it would fold perfectly. Okay? I could also do one there. If I took this corner and folded it to this corner, there would be no spaces, it would be perfect. And then the third line of symmetry would run there. So a regular triangle would have 3, just like it has 3 sides, just like it has 3 vertices. A regular pentagon, hopefully you're starting to guess how many lines of symmetry this perfectly drawn regular pentagon has. Again, if you draw a straight line of symmetry through each vertex, you will find that it has 5 lines of symmetry. Alright, and here at the bottom, it tells us, I guess. It says a line of symmetry divides a figure into mirror images. In each of these figures, a line of symmetry passes through a vertex and splits the opposite side into 2 segments of equal length. Okay, so it goes through the vertex here, and it splits the opposite side here into 2 equal parts. It would split it exactly in half. The regular triangle, maybe on your answer sheets, let's just write a small triangle. Let's put equals 3, and let's try to draw a pentagon, a 5-sided shape, and that one equals 5. Lines of symmetry. Example 2. Here we show a regular quadrilateral and a regular hexagon. Find the number of lines of symmetry in each figure. I guess the square is a little bit different than the other objects we've dealt with. Okay, let's do the square first. So draw a very small square on your answer sheet for example number 2, and let's figure out the lines of symmetry. We think that it would have, I guess, 4 because it has 4 sides, but with squares we go through the vertex and we actually go to the other vertex, so we're not going through a vertex and then splitting the other side in half. With this one, we split the square up, going through both vertex or both vertices, and then we can also split it up vertically and horizontally. And you know, it's not perfect, but I don't expect you to be perfect either. So if we count our lines of symmetry, we still have 1, 2, 3, 4, whereas we had a four-sided shape. So a four-sided shape, I guess a four-sided regular shape, a quadrilateral, a regular quadrilateral like a square, would have exactly 4 lines of symmetry. Let's just write LOS for lines of symmetry. Okay, now we also have a hexagon. Right? And I don't have a handy-dandy tool for a hexagon, so I have to do my best and draw this. Now, with the hexagon, we're also splitting them up. We're going through the vertices. If you see here, this would fold or this would mirror this image. So you go through the vertices, 1, 2, 3. Oof, I'm getting worse. All right, and you would also be able to go through the sides. Split this side in half and split this side directly in half, the side opposite it. And now if we split this one up according to our lines of symmetry, we would again have the same thing. And if you counted these lines of symmetry, we'd have 3 going through the vertices, we'd have 3 going through the sides, so we'd have 6 lines of symmetry. Okay?
Sorry,
no, it's okay.
You're doing your math lesson.
That's okay.
At your convenience, will you go through that with your kids?
Yes, I will.
And then that's kind of your process procedure.
All right.
So sorry about that. I should have known.
No, that's okay. Okay, got a little fast forwarding to do. Sorry about that. I had a person at the door. So for example number 2, we found that we had 4 lines of symmetry for a regular quadrilateral or a square. We had 6 lines of symmetry for a regular hexagon, or a hexagon with 6 equal angles and 6 equal sides. So I wrote 4 lines of symmetry and 6 lines of symmetry for example number 2. And that, page 690, it says, besides having reflective symmetry, regular polygons also have rotational symmetry. So here, my lines of symmetry were reflective. I drew a line down here, and the left side reflected the right side exactly. Now we're going to talk about rotational symmetry. A figure has rotational symmetry if it regains its original orientation more than once during a full turn. For example, if we rotate an equilateral triangle 1/3 of a turn, the triangle appears in its original orientation. All right. So I'm going to do my best to draw a perfect equilateral triangle. All right, now rotational symmetry. If I grab this triangle and I rotate it, ooh, that was poor. Okay, but if this would be a perfect equilateral triangle, as I rotated it that way, it would basically fall into the exact same spot that it was previously, and that's where we get our rotational symmetry. Okay, and it does that, of course, 3 times. In the book, they labeled each side A, B, and C so that we could understand where these points were going. Okay, as I rotated here, okay, C was where A was where B was where C was, but the shape is exactly the same. And it happens again when I rotate it here. And it happens again when I rotate it back to its original position. Okay, and when the projector kind of sends its image over here, it kind of distorts it a little bit. So it's not perfect to look at, but if you brought your books home, you can see the equilateral triangle on page 690. Okay, let's look at example 3. Rotational symmetry, again, is when you rotate it and it lands basically exactly where it was before you rotated. Okay, which of these letters has rotational symmetry? I have the letter M, the letter A, the letter T, and the letter H. Okay, if I rotate the letter M, does it ever look exactly like it did before I rotated it? No. So let's get rid of M. If I rotate the letter A, Does it ever look exactly the same as before I rotated it? No. What about T? Does that top ever look exactly right? No. Let's look at the H and see what happens here. Does it ever look exactly like it did before? Yes. Before I rotated it the full way, the full 360 degrees, it did have rotational symmetry. So, for example number 3, the letter that has rotational symmetry is H. Okay, let's look at example number 4. On the grid, there is an L-shaped figure and its reflection. Is there a line of symmetry between the figure and its image? Okay, I have another knock at the door. You can fast forward it a little bit.
Gotta take my inhaler.
Okay, so we're looking at example 4, and it says, does the two L-shaped objects on the grid, God, I forgot to shut the door. Okay, sorry again. Alright, example number 4 says, on the grid there is an L-shaped figure and its reflection. Is there a line of symmetry between the figure and its image? Okay, so we have a line, we have an L-shaped figure on both sides. Is there a line of symmetry between these two figures? Halfway between the figure and its reflection is the line of symmetry. So the line of symmetry runs right here, because if you imagine a mirror right here reflecting this image, I guess reflecting this image, it would basically be the exact same thing here. You could also take this image. I learned that reflective symmetry was just putting a line on it and folding it, and then both sides basically landed right on top of each other. So if I took this side and I folded it onto this side, it would be the exact same. So it does have a line of symmetry. If the vertical line, x equals 3, the line of symmetry is the line of its reflection. The figure on the right is the image of the figure on the left reflected across the line x equals 3. So do all reflections have a line of symmetry? Yes. So for example number 3, or example number 4, we're just putting yes. Okay, and sorry example number 4 took so long. But the line of symmetry, it doesn't necessarily have to run through an object or, I guess, directly beside an object. It can lie right in the middle of the objects, like it does in this instance in example number 4. Okay, example number 5. We again have a grid. It says, on the grid, an L-shaped figure is translated 4 units to the right. So they have an L shape and then they have another L shape. This time it's just translated 4 units to the right. Is there a line of symmetry between the figure and its translated image? If you could find a line of symmetry anywhere on here, okay, where this image would fold directly on the other image, you would have a line of symmetry. However, there is no line of symmetry on these two objects, because if I took and I folded this one, it would look like this. If I took and folded this one, it would look like this. They would never reflect directly on top of each other. So for example number 5, there is no line of symmetry between these two black objects that I've drawn first. We will cover example 6 and a few of the practice problems tomorrow, or I guess on Tuesday. I hope you have a great Easter break. Sorry for all the interruptions and all of the distractions, but if you needed to rewind it and double check your work and figure everything out, feel free to do that. Again, I will see you on Tuesday. Have a great Easter break.